All right, let's start chapter 2. In chapter 2, we're going to be focusing on how we organize and summarize the data. And we're going to be doing this through graphs, pie charts, bar graphs, histograms, that type of thing, as well as something that is called a frequency table or a frequency distribution. So that's what we're going to be focusing on 2.1 and 2.2. In 2.1, we're going to be focusing on qualitative data. So data that is categorical. And then in 2.2, we're going to be dealing with quantitative data. So data that is numbers. So let's get into 2.1. First, let's go over some vocabulary and talk about the stuff that we need to know. So number one, frequency distribution. So a frequency distribution is also referred to as a frequency table. It is going to list the category, the frequency of that category, and then it can also contain a relative frequency, and then sometimes it contains a percentage. Not all the time, not even most of the time, because percent is just another way of writing relative frequency, and typically they don't make you do both of those things. We also need to know the term raw data. Raw data is simply the data that we collect in the form that we collected it in. So no sort of organizing, sorting, nothing like that, just the data as it was collected. Frequency is the number of data points that fall into a certain category or a certain class, which we will get into a little bit later. Relative frequency. Relative frequency is a proportion. It is the number of data points that fall within a category divided by the total number of data points. And then when we deal with relative frequency distribution, we're simply writing down the relative frequency for each category. So let's get into what a frequency distribution or a frequency table looks like. And it looks like this, where you have your categories. So category 1, 2, 3, and 4. That could be favorite pet. It could be brand of car. It could be type of phone. It could be internet browser you use. Whatever your category is, you're going to list all of those categories in that first column. Your second column is typically going to be the frequency that you see that. So if we're talking about models of cars in the student parking lot, we go out, we write Ford, Chevy, Audi, whatever the car company is, and let's say I saw 35 Ford cars and trucks out in the parking lot, then I'd write Ford, and the next word I'd write 35. And that's what the frequency is. The relative frequency is going to be the number of data points from a particular category divided by the total number of data points. And then percentages, relative frequency times 100. Again, that percentage category isn't going to be in all or even most frequency tables or frequency distributions. The most common ones are going to be, you have to have the category, and then frequency and relative frequency are the two most common ones to look at. All right, so we are going to start, and we're actually going to start by filling in the second two columns. So they give us our categories. In this case, it is dealing with our favorite pets, and the options or the answers that we collected were dog, cat, fish, bird, and lizard. And then next to that shows the frequency of those animals being someone's favorite pet. Then for the relative frequency, we're going to take each of these numbers. So 232 divided by the total number of people that answered the question, 905, and that gives us our relative frequency, which is 0.2564. So pause this, go ahead and calculate the rest of those relative frequencies, and then convert those relative frequencies into a percent. And I will continue doing that on this sheet here so you can double check and make sure that you're doing it correctly. And then our final one, so there's our relative frequencies. And then to turn those into a percent, we multiply by 100, which means we are simply moving our decimal 2 places to the right. And so we would end up with 25.64%, 44.53%, 20%, 4.97%, and 4.86%. Now, quick checks as you're going through and doing these types of problems with distribution tables and distribution or frequency distributions and frequency tables, making sure that your numbers add up. You're going to be counting lots of raw data. In this case, they already gave you all of the frequencies, but there will be cases like our next example where you have to go through and count to find those frequencies. Double check those total numbers to make sure that you're on the right track. And then you can also do the same thing by double checking your relative frequencies and your percents to make sure you're coming up with reasonable answers. For my relative frequencies, when I add up all of those relative frequencies, what number should they add up to? Well, because we're dividing by the total number, and that total number comes from adding up all of the numerators, when I'm done, this relative frequency should be 1. Now, because we're rounding and things like that, maybe it's not 1, maybe it's 0.99999, or maybe it's 1.0001, something like that. If it's that type of issue where it's just a rounding mistake, that's okay. We can live with that. However, if you get a answer that is 0.98 or 1.02, that's most likely not our rounding error because we're rounding out to 4 decimal places and you're having a mistake within 2 decimal places. So that means you might want to go back and double check to make sure that you counted everything correctly. And if our relative frequency is 1, that means our percentage is going to be 100%. Excellent. Next, we are going to create our own frequency distribution for blood types. So again, take a second and we're going to fill this out. And the first thing you have to do is you have to fill in the categories. So determine by looking at our raw data what our categories need to be, and then go ahead and count the frequency of each of those categories, find the relative frequency, and then turn that relative frequency into a percent. Pause the video, and then when you're done with it, come on back and we will go over it as a class. All right, so hopefully you've done it. I'm going to go through and list the categories as I see them. So I see A, B, then AB, and O. So those are going to be my 4 categories. Those are the 4 different blood types that I have in my raw data. And then I'm going to go through and count each type. Now, there's different ways you can count. I don't care which way you do it. Just make sure you practice doing it the way that you like to do it so you don't make mistakes. Some people want to go through and find all of the A's first. Some people go through, and the way I tend to do it is I'll go through and I'll see, okay, there's 1 A, we have 2 B's, we have an AB, then 1, 2, 3 O's, another B, an AB. There we go. Another B, O, A, O, A, O, 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 A, B, A, B, O, B, A, B, A. I prefer to do it that way. I feel like it makes it easier for me to not skip something accidentally. But it's up to you. Then after you've made all of those tally marks, you go back through and you actually write the frequency. So this would be 5, 7, 4, and 9. So 5, 7, 4, and 9. Then after you've gone through and done that, we add up all of those numbers. So 5 plus 7 plus 4 plus 9 is equal to 25. Then, before you do anything else, your next step, count the number of raw data points. So go back up to your list and count how many data points are in here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 20, 21, 22, 23, 24, 25. If those two numbers don't match, everything else about this problem that you're doing is going to be wrong. Because in order to find relative frequency, you have to divide by that total. And if your total isn't the actual number, then you're not going to get it right. And if your total isn't the correct number, that's because you miscounted somewhere, which means one of these frequencies is off. So it is the easiest, quickest way to make sure you don't make a very big mistake. So take that time, go through, count the raw data, make sure it matches your frequency total before you move on. Next, again, we go through and we find the relative frequency of all of these. And then we can turn them all into a percent. And then we can do those totals to double check to make sure that our numbers match up and we've done that work correctly. So again, it's not difficult, but it can be tedious. You have to be very meticulous and careful when you're going through and counting that, especially as you start getting bigger data sets. So there won't be huge data sets on a test or anything like that, but you need to make sure that you are doing it correctly. It looks like my screen sharing stopped. 1 second. Oh, I'm going to pause this real fast and figure out what's going on. All right. So again, tedious, but not difficult. You just have to be careful and patient as you're going through and doing this. So make sure you practice that when you're doing your homework so that you can do it when you're taking a quiz or taking a test when you don't have multiple tries. All right, once we have this frequency distribution or our frequency table, we are going to use that to help us create different displays that make it easier to digest this information. And those displays that we're going to talk about are going to be bar graphs and pie charts for qualitative data. So we take our frequency distribution and we convert it into a visual display of the data, and that makes it easier for people to look at and kind of understand what's happening as opposed to just a table full of numbers. So the first thing we're going to talk about is bar graphs. A subset of bar graphs is called a Pareto chart. A Pareto chart is just a kind of sorted bar graph. Not a huge difference, not a huge focus. But in a Pareto chart, they go from the tallest bar or the highest frequency down to the lowest. That's the only difference. Whereas in a bar graph, the bars don't have to be arranged in any particular order. A Pareto chart, they do. That's the only difference. For the most part, we will be using bar graphs, so you don't need to worry about that. But it is a good vocabulary word to know. There are two different types of bar graphs. Essentially, they are the same. It is just the orientation of the graphs that make them different. We have vertical bar graphs and we have horizontal bar graphs. In a vertical bar graph, our x-axis is going to be our category. Our y-axis is either the frequency or the relative frequency, depending on what type of bar graph we're making. We can make frequency bar graphs or you can make relative frequency bar graphs. And that would depend on what your y scale is. You would change your y based on frequency or relative frequency. The second type is a horizontal bar graph. And a horizontal bar graph, the axes are flipped. So your y-axis becomes your category and the x-axis becomes your frequency or relative frequency. Other than that, they are the same, which means both types of graphs, and this is going to be true with all types of visual displays. So bar graphs, pie charts, histograms, dot plots, stem and leaf, any of those things, if we have a setup for it, so if the problem gives you kind of a backstory of what we were talking about, you need to make sure that you title and label axes of any visual display of data. So any type of chart you're making, I need to be able to look at that chart and tell exactly what it's telling me without having to go back and look at the raw data or look at the question. So make sure that when you're creating these, you include that title that tells the person looking at it what this data is about. And our first question, we're going to create a vertical bar graph showing relative frequency, so two big pieces, vertical and relative frequency, for the following data, which represents the number of high school students in after-school activities. So before we do anything else, vertical and relative frequency. So we're going to label our axes. So this is going to be relative frequency. And then our x-axis is going to be the category. And they've split our categories for us, which is freshman, sophomore, junior, senior. So down here, we're going to label it as your year in high school, or your grade in high school, or something to that effect. Then we need to title it. So the title of this graph is going to be something like relative frequency of high school students in after school activity. So relative frequency of high school students in after school activities. And again, it does not have to be the exact word for word title that I use, but it needs to convey that same message of what are we talking about? And then we're going to come in here and I need a total of 4 for I have 4 different categories. So I'm going to make each category 2. So I'm going to have freshman, sophomore, junior, I'm going to have SE and SO. Now, because I don't know what F and SO and J and SE are, I'm going to make a key. That tells my reader what each of these labels is. Now, if you wanted to write out freshman, sophomore, junior, senior underneath your bar graph, then you wouldn't need the key. But if you're going to use abbreviations as your categories, you need to somewhere in that visual display next to it, tell me what those abbreviations represent. So again, I can find everything out here. I don't need to go back to the original data. So now I've got my bar graph all set up, ready to go. The next thing I need to do is find out the relative frequency of each of these things. So start off with 25 divided by 250. And then we do that same thing all the way down. And we come out with half of the students enrolled in after school activities are seniors. Then on the next side, then we need to change or determine what scale we want to use for our y-axis. I think we should have enough to make every second space a tenth. So I've created my scale. And now I go ahead and I fill out my bar graph. So freshmen represent 10% or a relative frequency of 0.10. So that's the bar for freshmen. Sophomores are at 14, so that's just below that. Then we're at 0.26, so just above. And then there we have our bar graph. And that's how you create a bar graph. When we get into histograms, a histogram looks very similar to a bar graph, but it is with quantitative data. There's a couple of key distinctions. For a bar graph, we use categories, and there's going to be a space between each of our bars. So notice that there's a space between each category, and that is the way that you construct a bar graph. Ooh. All right, next, I want you to do something very similar, but this time you're going to be creating a horizontal bar graph, and it is going to be a frequency bar graph. So frequency and horizontal, that means this is going to be our frequency, and the y-axis is going to be our category. So pause, attempt to construct this horizontal bar graph, and then unpause when you're finished, and we can go over what it should look like. All right, so we knew the x-axis was going to be our frequency. Our y-axis is type of pet. And then our title for this is going to be frequency of favorite type of pet. Again, something like that. Doesn't have to be the same word for word. All right, then we're going to go ahead and we have to come up with all of our different categories. We have 5 different options. I believe I can make each category 2. So I'll start with cat, skip one, dog, fish, bird, lizard. Yep, and I think that works. And again, because I did not write out the whole name of the animal, I'm going to make a key that tells me what all of those are. All right, and then we need to look to see what our scale needs to be. So the biggest one is just over 400. So maybe we can go up by 50. So 50, then 100, 200, 300, 400, 500. And that looks like that worked out well. All right, then we go ahead and we actually fill in what our categories or what our frequencies should be. So cats between 200 and 250. So that's our cat. Dogs go out to just past 400. Got dog. Fish just under 200. Birds at 45, which is just below 50. And then lizards, almost the exact same. And there we have our horizontal bar graph. Again, key things that are important besides just the graph itself. We need labels for X and Y. We need a title of the graph. And if you use an abbreviation in your graph, you need to make a key so I know what those abbreviations represent. You'll see side-by-side bar graphs also for a comparison tool. Typically, those are dealing with two different populations, or sometimes they deal with two different dates. We don't see those a lot, but if it was dealing with favorite pets, maybe you would see a side-by-side bar graph where they would have data from 2000 and they'd make a bar graph of everyone's favorite pet from 2000 and they'd make those bars blue. And then they'd do the same thing, but from 2020 and they'd make those bars red. And then you could see how favorite pets have changed from 2000 to 2020. That's one way that you would see a side-by-side bar graph. It allows you to compare two different things. Or maybe they do something like gender. If they're talking about favorite pets, maybe they would do it from the same year. So they just did a survey last year, so in 2021, and then they would have the data for male and female. So maybe orange, they would have the favorite pets of females, and then in green, they would have the favorite pets of males, and you could see if gender played a role in what your favorite pet type was. So that's what a side-by-side bar graph can be used for. All right, last thing that we're going to talk about in 2.1, it's fairly short. Bar graphs and pie charts are the two big types of visual displays for qualitative data. And so we are going to get into pie charts or a pie graph, depending on what you want to call it. Again, you guys have probably seen this many, many times before, and there's not much different that I'm going to tell you, other than you need to make sure you make a key and you make sure you title all of your graphs. So when you're doing this, the percent, you don't have to be super accurate. We're not in here for a geometry class where we have to make very accurate sections and segments of our circle. As long as they are in kind of close proximity, if it's less than 45 degrees or more than 45 degrees, it needs to be more or less than a right angle, or 90 degrees and 180 and things like that. As long as you're kind of in that ballpark, it will be an accepted answer. The only reason you would need to know the exact number of degrees is for MSL, which is that MyStatLab. There can be a question on the homework where they will ask you to say exactly how many degrees should be in each kind of part of the pie chart. So you won't have to do that on a test. You won't have to do that on homework, but it may pop up on your homework. And if you wanted to find out how many degrees, you multiply your relative frequency or the percent in decimal form by the number of degrees in the circle. So that first one, we were talking about the different types of blood. We said the relative frequency of type A blood was 0.2. Well, if there are 360 degrees in a circle and 20% of those degrees need to be in the type A blood portion, that means we need to have 72 degrees in our arc. So again, not a big deal. It won't show up on a test or quiz, but if it asks for it on the homework, I want to make sure you understand that. And you get this answer by doing 360 degrees, which is the whole circle, times the relative frequency, which in this case is 0.2. And then you would do that for the rest of them as well. So 360 times 0.28, you get 100.8 degrees. 360 times 0.36, get 129.6. 57.6. And then if you add all of those up, we should get roughly 360 because those are the only portions of the circle that we're cutting it into. So those four need to add up to 360. Then, once we have that, we go ahead and we actually make our segments. So we have 72 degrees for A. Now, if I go like this, I know that is 90 degrees. Well, I know that type A blood is less than 90 degrees. It's 72 degrees. So I'm going to go like there. That should roughly cover my 72 degrees. And I'm going to put type A in there. Next, I'm going to go for B. And when I add A and B, that's almost 180 degrees. So that means almost half of my circle should be a combination of A and B. Not quite. So this line won't go straight down. Straight down would be exactly 180. It's a little bit less than that. So I'm going to move this guy in a little bit here. And that's going to represent my B. And then I have a almost 60 degree wedge. So something like that for AB. And this leftover part is O. So that's what a pie graph looks like. Now you can use different colors. If you don't have enough room to write in the label for each one, in this case, it was a big circle and very small categories, A, B, O, AB. That's very easy to write. If we were doing favorite pet type here, it might be a lot harder to write lizard in a very small section. So you would have to make a key. Either way, I need to put blood type up here so I know what we're talking about. I'm still going to make a key, and my key is going to consist of a couple things. First, if I used abbreviations in my pie chart, I'm going to make sure that I've written out what those abbreviations are. And second, I'm going to represent, or I'm going to put in what the relative frequency is supposed to be. That way I know this A looks like it's more than 90 or more than 0.25, which would be a quarter of the circle. I can look over and say, oh, it's supposed to be 0.23. Okay, I'll give it to you. So make sure you write out the relative frequency or the percent and any abbreviations you used. So I didn't use any abbreviations, so I'm going to use A as 0.2, B 0.28, not C, there's no type C blood. O is 0.36, and AB is 0.16. And so you'll need a key for all pie charts for that part there. And then you'll also need to include any abbreviations that you used as part of your pie chart. All right, that is the end of 2.1. In 2.2, we'll deal with quantitative data and how we handle that.